Today's lesson we're going to talk about direct variation. Two big things we're going to talk about are direct variation and the constant of variation. Here's an example of something with direct variation. A recipe for paella calls for 1 cup of rice to make 5 servings. In other words, a chef needs 1 cup of rice for every 5 servings. Direct variation. Direct means it goes 1 and 1. Variation, it's how it changes. So here, for 1 cup of rice, it makes 5 servings. 2 makes 10, 3, 15, 4 is 20. The equation y equals 5x describes the relationship. In this relationship, the number of servings varies directly with the number of cups of rice. This number right here, this 5, is called constant of variation. In y equals 5x, it looks very similar to something else. What would that 5 be called another way? What's another word for that 5? What have we been dealing with for a while now? Slope. Constant of variation, direct variation. We're talking about an equation where we have y equals kx. K is the non-zero constant. It's your slope. The difference between this and a normal equation, there's no other numbers. It's just y equals kf. I have y equals 3x. I want to tell whether or not this equation represents a direct variation. If it does, we want to know what the constant of variation is. Is this in the form of y equals kx? Yes. What would be my k? What would be my constant? 3. So the constant is 3. How about this one? I have 3x plus y equals 8. Can that be put into the form of y equals kx? Even if I rearrange this, I'm going to have this 8 here. Because this 8 is here, it is not a direct variation problem. How about this one? No. Are you sure? I know that you see different numbers going on. But this is a 0. I can take this and move it to the other side. How do I move this from this side to the other side? I need to add it to both sides. So if I just move something from the left to the right-hand side, it changes the sign. How do I solve for y? Divide both sides by 3. I have y equals 4/3 x. For this problem, this is now direct variation. My constant variable is 4/3. This means for every step of x, it goes up 4/3. This one here, y equals 4/3 x plus 1/3. Is this a direct variation problem? Is it in the form of y equals kx? It can only be y equals something x. Because this piece is right here, it's not a direct variation problem. All right, seems like you're getting the idea of it. Now, sometimes you're not just given an equation, you're given a table. So we got to write an equation. Here are my x's, here are my y's. I need to find the constant of variation. To find the constant of variation. Here, if I have y equals kx, how do I solve for k? Divide by x, divide by x. K is a y value over an x value. Give me a y value. 6. What's the x value that is directly attached to that? The 2. What's 6 divided by 2? 3. Now, I didn't have to pick that one. I could have picked this one, the last one. 18 over 6. What's 18 over 6? 3. What's 12 over 4? Doesn't matter which one you pick, every constant is going to be the same. So I take a y value divided by an x value. My answer is y equals 3x. This means for every change in x, it goes up 3. So if I put in 6, what's 3 times 6? That's what I get as an answer. If I put in 10, what's 3 times 10? So if this was a 10 here, the answer would be 30. You take a y divided by x to get me the constant. Then it's just y equals constant x. I'm going to go back. I'm going to show you the ordered pair. You can do it that method, or we can do it the way we used from the last section, using the slope formula. Slope formula you just told me was what? y2 minus y1 over x2 minus x1. Give me a y value. 12. Give me another y value. 18. What's the x value that corresponds to the 12? 4 minus 6. 12 minus 18 is negative 6. 4 minus 6, negative 2. Negative 6 over negative 2, 3. I got the same answer this way than what I did this way. This method here, method 1, only works for direct variation. If I can take and go, this is 3, this is 3, this is 3, I know it's direct variation. Try this one. Is this a direct variation relationship? Easiest way is to look. What's negative 2 divided by 1? Negative 2. What's 0 divided by 3? Because they're not the same, it is not a direct variation problem. They all have to be the same. Here's the other type of way you'll see direct variation. The value of y varies directly with x. Direct variation. Y is 3 when x is 9. Find y when x is 21. Just like pretty much everything else, there's a couple ways to solve this problem. First method is to find k and then write the equation. I can find k with what is given to me. We know that y is 3 when x is 9. How can I find k? Y divided by x, which is 3 over 9. 3 over 9 means 1/3. So y equals 1/3 x. With that being said now, we want to find out what the answer is when x is 21. So I'm going to take this 21, put it in there. Y equals 1/3 times 21. 1/3 is the same thing as dividing by 3. So it's 21 divided by 3. Y is 7. So you take what they give you. You look at the part that says, y is this when x is that. You find out what k is. You make it y equals kx. And that says, for every step in x, it's changing by 1/3. It's being divided by 3. Substitute in the x they give you, or the y they give you, and solve. Method 2 is using a proportion. And this is the method I usually use. Same exact problem, I'm just different method. Y is 3 when x is 9. So again, we had y over x. Y is 3, x is 9. Equals. Now, this is what I'm trying to find. Which one am I trying to find? Where does y go? On top. X is 21. I put 21 on the bottom. Solving a proportion. 9 times y, 9y. 3 times 21, 63. Divide by 9. Y is 7. Different method gave me the same answer. I usually use this way because if I'm missing my x, this problem I have to do more work to rearrange to solve. This one can take longer than this one. I don't care which method you use. Some people will even try the guess and check method and try to figure out what works. It's great if you have whole numbers and it comes up nice and neat. But sometimes you have decimals and fractions which you might sit and guess forever. Try this one. The value of y varies directly with x. That's pretty much how they're always going to start off. That sentence is going to be there. Y is 4.5 when x is 0.5. Find y when x is 10. I don't care if you use method 1 or method 2. Which method did we use? 1 or 2? 2. So let's just look at 2 first. Y over x. Doesn't matter if I go y over x or x over y, but I'm writing it off to the side so I know myself how to set it up. And what they tell me, how do I set it up? How do I set up the left side of the proportion? 4.5 over 0.5. What about the second part? Y over 10. I'm missing my y, so I put a y. If I was missing my x, the x goes down here. I cross multiply. 0.5y equals 45. Divide by 0.5. Now, I'm not using a calculator here. I'm going to move the decimal point over 1 and make that a 5. If I do that on the bottom, I have to do that on the top. So I have 450 over 5. How many times is 5 going to 45? 9, and then there's a 0 left over. 90. I know it's easier just to go in a calculator, but I'm trying to teach you how to do math without a calculator. It's just get rid of the decimal. I only had to move it over 1. Whatever you do to the bottom, you have to do to the top. And I know 5 goes into 45. The other method, I have to find k. K is y over x. Move the decimal point over one place here, move it over one place here. It says 45 over 5, which is 9. Y equals 9x. I substitute in my 10. Y equals 9 times 10. Y is 90. Both methods work. I usually do this method. Someone's saying 45 divided by 0.5. Because you're thinking cutting it in half. You're not taking half of 45. You're taking 45 and dividing by half. So it's really taking 45 divided by a half. Now, I don't like fractions over fractions. This divide or fraction really means divide. So it's 45 divided by half. But we don't divide fractions. We multiply by the reciprocal. The reciprocal of 1/2 is 2. 45 times 2 is 90. A group of people are tubing down a river at an average speed of 2 miles per hour. Write a direct variation equation that gives the number of miles y that the people will float in x hours. What's my constant? 2 miles per hour. That's what a direct variation is. You just have something that's changing. You go 2 miles an hour, so for every hour you go 2 miles. So my equation is y equals 2x. I'm going to need the graph. So I'm going to make a table first. I'll just make a little t-chart. 0, 1, 2, 3. After 0 hours, how far did they float? 0. They didn't go anywhere. In every single direct variation problem, 0 has to be 0. If you put in 0 and you don't get 0, you know you don't have a direct variation problem. And other examples of direct variation. If you work a job, you get paid per hour. If you work 0 hours that week, how much do you get paid? 0 money. You get $0 if you don't work. That's what direct variation is. If you're not in the water tubing, then you're not moving at all. After 1 hour of tubing, how far did they go? Do you guys know what tubing even is? You sit in the inner tube, and you sit in the river and you just float. That's what. You don't have to pay for. I mean, what's that? No, you just float. It's like going to wave pool and being at the lazy river. That's what you're doing. After 2 hours, 4. 3 hours is 6. All right. So our graph. Now for direct variation graphs, we only need to worry about the first quadrant. Some of you might have heard about the quadrants before. This is your first quadrant, second quadrant, third quadrant, fourth quadrant. No. You can't have anything in the negatives. You can't have negative anything. You can't make negative money. You can't have negative time. So it's only going to be in this region. Always.
You could have negative money.
Not if you're working. You can't work negative 2 hours. That's a different aspect. But if you're talking about a constant variation, though, you can't work negative 5 hours a week. The lowest you can work is 0. If you're driving, you can't go negative miles per hour. And I know some of you are thinking, I'm going backwards. Even if you're going backwards, you're still going somewhere in a speed. All right, 0's 0. 1 is 2. 2 is 4. 3 is 6. It is a perfect straight line, like there. So the more hours that pass, the farther in miles they go. Questions?